This video is mainly for my new subscribers that are not familiar with the flow of how our group generally likes to present our work. Nathan, on his Old Man Builds channel, has been such a great host for discussions related to anti-gravity and Overunity electric power systems. He generally has a live stream on the days and times displayed in red, and you can tune in to join the live stream discussions where we hash out differences in opinions and emphasize the importance of hands-on experimental verification. We try to take suggestions and experiments that are recommended from the live chat streamers and give them the shout-out they deserve. It takes a group effort like Nathan's channel in order to spread this information as efficiently as possible, and I thank him for providing such a fruitful platform. A link to his channel is available in the description. This video is a recap on my first live stream with Nathan, where some of the important information shared is compiled into a shorter version. The full presentation will also be available in the description section.
So the Tesla homopolar generator, it's actually a bipolar generator, if you will. So you can either use an electromagnet coil here, which would be underneath, or a permanent magnet, and say this is the north center and this is the south center. As this is a conductive belt, so he's spinning it with a conductive belt, and as these two discs spin, the electrons here, say, will experience a centrifugal force due to the Lorentz force, okay? Comes through this conductive belt and goes centripetally towards this terminal, and then it comes out to the load, and the cycle repeats with this conductive belt. And he taps it off right here, and it lowers the friction of the homopolar generator. And spin on it was using fluids instead of solid discs. And just keep this in mind as I present it. It's kind of heavy, so I gotta hold on one second. I'm just now streaming for the first time, so I gotta get used to it. But
yeah, we're all good.
It's this guy here I've been working on in the background. It's the same thing. I ordered the parts and just threw it together as like a prototype demonstration. But so I'm just using two drills as the motors there. And inside these jugs would be a conductive fluid. They look blue because I was using copper sulfate. But I have speaker toroidal magnets on the bottom and everything, and I tap it off from the bottom there. But it's the same principle. You're just spinning a conductor through a magnetic field and using Lorentz forces to generate high current. Now, it's high current with very low voltage. That's the whole point of these generators. But they can easily get up to 100 volts. Then you can tie that in with any high voltage generator, and then you get a hybrid system where it's similar to the Statica, where he used a Wimshurst type of high voltage generator. These can go easy 1,000 volts. So if you were to have married together 1,000 volts conservatively, 100 amps conservatively, that's 100 kilowatts. Okay. The Testatica actually powered a small community. I think it's Methermita in Switzerland or something. And it's really the practicality, like in a grid down, you take jugs, you take speaker magnets, conductive fluid. So the power system's easy, and the focus of this channel, I believe, is propulsion.
That's really cool. So let's get into how the energies combine, because a lot of people are not going to understand that right away. So can you explain that?
That is tricky. There's several ways you can do it. Like I said, the Wimshurst is probably not the best. I mean, you could do it with the taser module. Uh-oh.
Yeah, kind of missing you there.
Yeah, my camera went out. That's okay. You can do it with any high voltage generator. You can use the back EMF to separate the say battery, pumping an inductor, open the circuit with the relay and use the back EMF. And that way they're separate, because that back EMF will give you a high voltage that can be sent through that. And since the battery circuit's open at that moment, they're isolated. That's one way of doing it. Another one is an Overunity plug. One end connected to ground, and then the other end, the two diodes that split off, you can use those two. So, if you know about Overunity plugs, you're converting the AC to DC, but it's a one-line system where one line is connected to the earth, and then the two diodes are where you would send that voltage through the bipolar, I guess I'll call it Tesla fluid turbine or fluid dynamo. But there's several ways if you're creative. I can maybe discuss more on it later. I literally just built it within this past week to show today.
Okay. Well, I always have to ask, because you know what? Sometimes people get into things and they go, well, this is just an amp motor. And then they go, well, this is just a voltage source. And combining the two makes a big deal in understanding how to get generators to work better. Because sometimes you want something that produces pure amps, so you can get them higher. Sometimes you want pure voltage, but the combination really makes the biggest factor out of everything.
Yeah.
Let's see. Walter, well, I can't read that name. Final setup is making FE devices and creating an electric. Okay. So I'm actually interested in this. We were talking about 2 weeks ago, as we said earlier, about the homopolar generator and how it just puts off the amps. So let me ask you something. You said that Tesla did it with a belt that goes around it. Do you think that belt was getting electrostatics to add into the amperage on that motor?
Yeah, Tribe Electric could play a part there, but he used like a conductive chain kind of thing, from what I understand. So he was going for a low resistance, but you can increase the voltage with Tribo Electrics, that type of effect with the, you need a low resistance, but you can still Tribo electrically charge it as it's doing it to get some natural voltage on it.
Well, I asked that because you basically can take a static generator and put brushes on the belt, and you're going to get an electrostatic charge. And then you get the motor turning and you get the amps coming out of the homopolar motor right there.
Right.
So I'm just wondering if in some way you'd still have to recombine them. You know what I mean? Just kind of like you're doing.
Yeah, the recombination is where I'd have to get a little bit deeper at a different time. But know that there is a small community that's powered with Testatica, and it's a similar system.
So let's take a look at this real quick. This is the Testatica machine. So do you think on that backplate you see the stuff that looks like the Wimhurst, but do you think there's also a homopolar or basically a magnet behind it, just like
well, you see those two black knobs on top of the two condensers or capacitors that he was using, those big jars? It's similar to mine, right?
Right.
Imagine if it were a motor, or if there's a spiral coil going down the middle of those capacitors, it would produce the magnetic field without using speaker magnets, kind of thing.
Okay.
Those jars he used was the big secret, you know what I mean? And my twist is, using those jars as a homopolar generator, or, bipolar, really. But
well, in doing this, it basically is taking, there's static electricity there, but if you combine it with the homopolar, I keep saying that, just combine it with the magnet and get straight, you know what I mean, amps out of it, then you can combine them in that thing there, or you could just do the back as the homopolar generator, and then you could use in basically a DC flyback setup in those two cylinders in order to get an AC, basically a potential voltage coming out of it.
Right. I would say a slower pulsed flyback type of thing would be the first way I would try to go about that. It doesn't have to be high frequency or anything, because, you know, just want to build up a current into a coil slowly and then rapidly open the circuit. And that's where you get that high voltage, but that's sent through the canisters, if you will. And while it's doing that, you know, your battery is then open, so that they're isolated, because you're opening the switch, battery's isolated, but that collapse is going through the two canisters. So you get the voltage while the battery is even open.
So it may turn out to be that in itself is the power source, along with the actual fields necessary to create the craft.
Yeah. Yeah. This is the power source. The propulsion, I have, you know, if I can share, let's see. Hold on one second, please. So just a basic thing, when you have, you know, a poloidal wrap is this. This is like the center of a donut. And when you're wrapping this way, you get what's called an A field. Also, the magnetic vector potential here. Okay. And when you have like a permanent magnet in a coil that's just wrapped this way, and you pulse the coil, the electric field is, the A field is the electric field, but it looks like a magnetic field. You know, it's an unconventional electric field, basically. But when you have a permanent magnet here, it's magnetically parallel to this A field. You get a vortex spin, and that's why the magnets will spin if you pulse it correctly. Just having this wrapping, those coils go around. You know, they're beautiful in geometry, but every time it makes this loop, you get an A field. And I call it the Ghostbuster field. They say don't cross the field. A and B perpendicular, it causes the magnet to spin. But to get propulsion, you can use this A field with an electret here, and it'll bounce the electret up. Spin, it's good to use a magnet in there, but if you use an electret in here, you literally get a bounce, because this A field resembles an electric field, but you have to pulse this poloid. If that makes any sense.
Makes sense. Can you see the screen?
So one A field has zero divergence and the other has non-zero divergence.
Okay.
So the divergence, and that's where it's related to the rate of change. And all goes back to Tesla. He was saying it's more about the rate of change than the frequency. The frequency is easy. I mean, you just put it into a tank circuit, and the frequency is just your harmonic, you know. But the rate of change is where you get these divergence in the A field. It's really a matter of quickly opening and quickly shutting the circuit, like Steinmetz said. But easy propulsion is just using the magnetic vector potential by pulsing a poloidal round coil while having an electric in the middle. But when you have the magnetic field too, that's where you get a vortex. Okay, if you just want a solid propulsion, all you need is a poloidal round coil and an electric. But if you want vortex and have more control of just going up, you know what I mean, and have more control of left and right, you're going to have some sort of magnetic field involved with that. But definitely implosion is where you get the implosion of the magnetic field specifically is where you get that cold, because you can use a relay and mechanical relay, and when you open the switch, like the core of that relay gets cold just because of the difference between the slow buildup of the magnetic field and the open, and then it collapses. The core of the magnetic the relay gets colder just because that collapse was more rapid than it expanding in its field. Its rate of change, it's all that stuff. Just like refrigeration, you can't just run something without some sort of rapid rate of change.